My name's Doug Bowie. I work for the School of Emerging Communication Technology. I'm a network administrator. I build all the infrastructure that faculty, staff, and students use to do all of our amazing coursework, lab work, research, all that kind of stuff. I work with a number of other staff colleagues in other departments and in even our own department to make cool experiences for students, faculty, and staff. This demo that I've got set up for you today is from ITS 4570, which is a crazy router class. And it's one of our senior electives. And we're doing a demo today on VPNs and VLANs. So security of a couple different types, some a little lower level, others across the internet kind of level. And it's one of our Midland level complexity labs. We'll be using GNS3, Generic Network Simulator 3, which is a virtual machine that we host in our data center that we provide one session for every student. So that way they can have a personalized network experience while they work on their labs. Inside GNS3, it hosts another number of other objects or virtual machines that can be a number of other environments. So we'll run Voios for a router. We'll run several different flavors of Ubuntu, desktop and server, to act as applications or act as clients. We can run several different flavors of Windows. There are a number of other test objects that run in the GNS3 environment. We use it fairly extensively to model networking environments of a variety of different types. It lets us look at what's going across the wire using Wireshark so that we can see the packets as they fly from object to object, computer to computer, environment to environment. We can see encrypted traffic, unencrypted traffic, and it allows us to really tear apart and look at what's going on so the students can troubleshoot, look into issues that are going on with their project. Today's exercise, we'll be looking at site-to-site open VPN connectivity along with local VLAN tagging to do VLAN trunks and access points. All right, so on one side, we've got our GitHub repo that shows the network diagram of what we're gonna build. And on our other monitor over here, we've got GNS3 that I brought up where I've already built it. And you'll see we've got kind of a remote office with a Voios that connects to the internet. And we've got our home office that also has Voios and two different VLAN connectivities. And then our red dot represents the VPN that goes across. And so it'll encrypt as it goes over the wild, wild internet between our two sites. So for example, we might be a shoe store and we might have home office and a remote shoe store, and we want to be able to transfer data between them for point of sale terminals. And we want that encrypted, right? We don't want our PCI data to fly around on the internet unencrypted. So we might use a VPN tunnel to do that. So this is GNS3 here that we can see, and this is very similar to the diagram that I just had up. We have two Voios routers. We've got a switch that understands VLAN trunks and between the two different VLANs we have set up. And we've got the consoles for each one of our objects down here. So we've got a Voios 1 console, and we'll be able to look at other Voios consoles. You can see the variety of them that go. So we can look at both of our Voios consoles as we do configurations on each of the Voioses. And you can see these are our internet clouds that we're connected to as we pass traffic back and forth. The student will have two different primary learning objectives in this lab. The first will be setting up the VPN tunnel between the two Voios connections to set up the encrypted tunnel. So we can do site-to-site VPN. And in our case, we implement OpenVPN. There are a number of VPN technologies we could use. This one happens to be one that Voios supports that we use, but there are a number of other ones. The second learning objective would be VLANs, which happen on the right side here. There's a VLAN trunk between Voios 1 and the switch. And then the switch is configured in such a way to spin out each one of the VLANs to either side so that we can have layer 2, distinct layer 2 traffic that's separated.